What if I told you one country is building a dam 3 times more powerful than anything that exists, or drilling tunnels through rock so hot it melts equipment, or constructing railways across altitudes where humans can barely breathe? While most nations struggle with basic infrastructure repairs, China is building projects that sound like science fiction. Dams that can power 300 million people, railways that climb 3,000 meters through earthquake zones, bridges that stretch 55 kilometers across open ocean. These aren't concepts, they're under construction right now, and the scale is almost impossible to comprehend. We spent weeks researching Chinese engineering projects, tracking construction timelines, and analyzing budgets that exceed the GDP of entire nations. What we found reveals something bigger than just infrastructure. It reveals a nation reshaping the world's physical landscape while everyone else watches. These are the 10 most extreme Chinese mega-projects under construction. They're building for the next century. Project number 10, Pinglu Canal. Let's start with something that opens this year. The Pinglu Canal, a 134-kilometer waterway linking Nanning, the capital of Guangxi province, directly to the ocean via the Gulf of Tonkin. Why does this matter? Because right now, goods from inland southwestern China have to take a 2,000-kilometer detour through the Pearl River Delta to reach the sea. This canal cuts that distance by 560 kilometers. It saves time, it saves fuel. It opens southwestern China to direct global shipping. Construction started in 2022. It opens in 2026, within months. But here's what makes it extreme. Engineers had to move 50 million cubic meters of earth, build 11 locks, and create a system that handles ships up to 5,000 tons. That's like digging the Suez Canal's little brother in 4 years. And it's just number 10 on this list. Project number 9, Kela Hydropower Station. Now let's talk about altitude. The Kela Hydropower Station sits 4,600 meters above sea level. That's higher than most mountains in Europe. At that altitude, oxygen levels are 40% lower than sea level. Workers can barely breathe. Equipment struggles to function, and weather conditions are brutal. But China built it anyway. Construction started in 2022. The plant began generating power in June 2023, 1 year. At nearly 5,000 meters altitude, it produces 2 billion kilowatt hours annually, enough to replace 600,000 tons of coal, reducing CO2 emissions by 1.6 million tons per year. The challenge: everything. Materials had to be transported up mountain roads. Workers rotated in shifts because of altitude sickness. And the entire structure had to withstand extreme weather. Storms, blizzards, freezing temperatures, all while operating continuously. Most countries wouldn't even attempt this. China finished it in a year. Project number 8, Xiong'an New City. Forget skyscrapers. China is building an entire city from nothing. A megacity designed to relieve pressure from Beijing by relocating government functions, universities, and state-owned enterprises. The target size? 2,000 square kilometers. That's larger than Shenzhen, larger than most cities in Europe. And it's not just any city. It's designed to be the world's smartest city. Autonomous vehicles, underground logistics networks, green energy throughout, zero carbon footprint. Construction began in 2017. By 2025, institutional anchors are in place. Infrastructure is functioning. Early-stage economic activity is underway. The investment? Over 1 trillion yuan. That's $140 billion to build an entire city from scratch in less than a decade. Most nations can't build a single airport terminal in that time. China is building a city the size of London. Project number 7. CR450 high-speed train speed. Let's talk about speed. In June 2023, China tested the CR450 high-speed train. It reached 453 kilometers per hour. That's 281 miles per hour. Faster than a Boeing 737 at takeoff, on tracks, with passengers. When this train enters full operation, it will cover the distance between Beijing and Shanghai in 2.5 hours. That's 1,300 kilometers in 150 minutes. For comparison, Japan's Shinkansen averages 285 kilometers per hour. Europe's fastest trains top out at 320. China just built something 40% faster, and they're not stopping there. The CR450 project aims for commercial speeds of 400 kilometers per hour by 2025, with experimental speeds potentially hitting 500. That's as fast as most commercial airplanes at cruising altitude. On the ground. Project number 6. Shanghai Tower. Let's go vertical. The Shanghai Tower, 632 meters tall, 128 floors, the second tallest building in the world. But height isn't what makes this extreme, it's the design. The entire tower spirals as it rises, a 120-degree twist from bottom to top. Why? Wind. Shanghai gets hit by typhoons. Normal skyscrapers at this height face enormous wind loads. They sway, they stress, they require massive structural support. But the Shanghai Tower's spiral design channels airflow around the building. It reduces wind loads by 24%. That means less steel, less weight, less cost, and a building that's actually safer during storms than traditional designs. Construction finished in 2015. It took 7 years. 9 cylindrical steel tubes connected by outriggers form the core. Curved glass panels wrap the exterior. And the result? A skyscraper that looks like it's twisting into the sky. But here's the real innovation. The tower is 55% more energy efficient than conventional skyscrapers. Wind turbines, rainwater collection, geothermal heating. It's not just tall, it's smart. Project number 5. Fast Radio Telescope. Now let's look up. FAST, the 500-meter aperture spherical radio telescope. It's the world's largest single-dish radio telescope. And it's not even close. 500 meters in diameter. That's half a kilometer. Built into a natural valley in Guizhou province. Why build it? To listen to space, to detect pulsars, to search for extraterrestrial signals, to study the universe. Construction started in 2011. It became operational in 2016. Just 5 years. And since 2017, FAST has identified over 740 pulsars, neutron stars spinning at impossible speeds, emitting radio waves we can detect from Earth. For context, before FAST, the world's largest radio telescope was the Arecibo Observatory in Puerto Rico. It was 305 meters in diameter. FAST is 64% larger and more sensitive. It can detect radio signals 2.5 times weaker than Arecibo could. The construction challenge? Relocating 9,000 people from the valley, building 4,450 individual panels that form the dish, and creating a system that can tilt to focus on different parts of the sky, all in remote mountainous terrain. China did it in 5 years. Project number 4. Kong-Zhuhai-Macau Bridge. Let's cross an ocean. The Kong-Zhuhai-Macau Bridge, 55 kilometers long, connecting 3 major cities across the Pearl River Delta. It's the world's longest sea crossing, not the longest bridge, the longest sea crossing. Because it's not just a bridge, it's a system. Bridges, tunnels, artificial islands. Why the complexity? Shipping lanes. The Pearl River Delta is one of the world's busiest shipping zones. Massive container ships pass through constantly. So engineers couldn't just build a bridge. Ships wouldn't fit under it. Instead, they built a combination. Bridges where the water is shallow. A 6.7-kilometer underwater tunnel where ships pass overhead. And 2 artificial islands to connect them. Construction took 9 years, finished in 2018. The challenge? Typhoons, earthquakes, saltwater corrosion, and ship strikes. The bridge had to withstand magnitude 8 earthquakes, category 16 typhoons, and direct hits from 300,000-ton vessels. So, engineers used 420,000 tons of steel, built foundations 200 meters deep into the seabed, and created a structure designed to last 120 years. Before this bridge, traveling between Hong Kong and Zhuhai took 4 hours. Now it takes 30 minutes. That's what $20 billion of engineering can do. Project number 3, Xinjiang-Tibet Railway. Now let's talk about altitude and distance. The Xinjiang-Tibet Railway, 1,980 kilometers, connecting Xinjiang in the northwest to Lhasa in the southwest. It's been called the project of the century, not by Chinese media, by international engineering journals. Why? Because the average altitude is over 4,500 meters. That's higher than any point in the continental United States, higher than Mont Blanc, higher than most of the Alps, for 1,980 kilometers. Continuous. The railway crosses mountain ranges, glaciers, permafrost zones, and some of the most remote terrain on Earth. Construction begins in November 2025. Estimated completion, 2035. 10 years. The budget, $56 billion. That's $28 million per kilometer. For comparison, high-speed rail in flat terrain costs about $10 million per kilometer. This is nearly 3 times more expensive, because everything is harder at 4,500 meters. Workers need oxygen. Equipment needs to be specially designed. Materials have to be transported across impossible distances. And permafrost. The ground freezes and thaws with seasons. That destabilizes everything. Tracks shift. Foundations crack. So engineers are developing new technologies. Heat-resistant concrete, self-adjusting track systems, and tunnels designed to handle ground movement. It's not just a railway, it's a research project. And when it's done, project number 2, Sichuan-Tibet Railway. Let's talk about the most difficult railway ever attempted, the Sichuan-Tibet Railway. 1,629 kilometers from Chengdu to Lhasa. Why is it the hardest? Because engineers are drilling through rock at 89 degrees Celsius. That's 192 Fahrenheit. Hot enough to burn skin on contact. Hot enough to melt equipment. Why is the rock so hot? Because the Tibetan Plateau was created when the Indian subcontinent collided with Asia. That tectonic collision trapped enormous heat inside the elevated crust. And now engineers have to tunnel through it. 70% of the railway is tunnels, over 1,100 kilometers underground. But heat isn't the only problem. The railway crosses 40 major fault lines, more than any previous rail project. That means earthquakes, constant seismic activity, ground that shifts without warning, and altitude. The railway climbs 3,000 meters. From 300 meters in the Sichuan Basin to 3,600 meters on the Tibetan Plateau. One section has a bridge-tunnel ratio of 94.8%. That means only 5.2% of the track is on normal ground. The rest? Bridges over gorges, or tunnels through mountains. Construction started in 2014. Sections are already open. The Lhasa-Ningchi segment operates now. The hardest section, Ya'an to Ningchi, is under construction. Estimated completion, 2030. When finished, the journey from Chengdu to Lhasa will take 13 hours. Currently, It takes 48, but the cost? $44 billion. And that's just the railway. Add in the research, the new construction techniques, and the lives of workers operating in impossible conditions. This is engineering at the absolute edge of what's possible. Project number 1, Yarlung Tsangpo Mega Dam. And now, number 1. The biggest, the most extreme, the most controversial. The Yarlung Tsangpo Mega Dam. Construction officially began in July 2025. Location? The Tibetan Plateau, near the Great Bend, where the Yarlung Tsangpo River drops 2,000 meters in just 50 kilometers. That descent creates more hydropower potential than anywhere else on Earth. The numbers? 60,000 megawatts of capacity, 300 billion kilowatt hours per year. Let me put that in perspective. The Three Gorges Dam, currently the world's largest, generates 22,500 megawatts. This will be triple that. This single dam will generate enough electricity to power 300 million people. That's roughly the entire population of the United States, or equivalent to the United Kingdom's total annual electricity consumption from one dam. The budget? $168 billion. That's more than the GDP of Hungary, or New Zealand, or Ukraine. And the engineering challenge? Unprecedented. First, altitude. The construction site is in the Himalayas. Remote, difficult to access. High altitude makes every task harder. Second, seismic activity. The region sits on active fault lines. Earthquakes are common. Engineers have to design for ground movement. Third, environmental impact. The dam will alter the flow of the Yarlung Tsangpo River. In India, it becomes the Brahmaputra. In Bangladesh, the Jamuna. Over 130 million people downstream depend on this river for irrigation, for fishing, for drinking water. So the geopolitics are intense. India has expressed concerns. Bangladesh is watching closely. China says the project won't affect downstream flows. But here's what's undeniable. This will be the largest source of clean energy ever built. It will help China reach carbon neutrality by 2060. And it will provide the electricity needed to power artificial intelligence, electric vehicles, and industrial growth. Construction timeline, 2025 to 2035. 10 years, if everything goes according to plan. The first turbines come online by 2031. But this isn't just about electricity. It's about control. Control over water, control over energy, control over a region that borders India. And it's about showing the world what China can do. That no project is too big, no location too remote, no challenge too difficult. So what does this mean? It means the world's physical infrastructure is being rebuilt, and China is leading that transformation. While other nations debate funding, while projects get delayed, while costs spiral, China is building. Not perfectly, not without controversy, not without environmental and geopolitical consequences, but they're building at a scale and speed no other nation can match. And by 2035, the world will look different. That's the power of mega projects. They don't just connect places, they change what's possible. And right now, China is defining what's possible. Which project shocked you the most? Let me know in the comments. If you want to see more content on global infrastructure and the projects reshaping our world, subscribe to The Global Build. Until next time.